Now we're going to continue with our lesson on vectors here. I've created another example, so I've created 3 new vectors. We've got some random instruments, number of strings, and whether or not they've been performed. And here we've got a new type of vector, which is a logical vector. So you have to make sure that you capitalize all the letters, and you'll know if you've got it right when it changes color. So now we're going to look at ways of getting the individual values in these vectors without having to look at the vectors themselves. The benefits of this may not be obvious with such small vectors, but once we start working with really huge vectors and huge data sets, it's going to be much easier to know how to find these values without having to scroll through lots of data. But we're going to practice on these small ones just so we can check ourselves. So let's start with trying to get R to print out a list of instruments that have been performed. So when you have 3 vectors like this, all of which have 5 data points, you can relate them. And what R will do is it'll say, okay, the first position in each of these vectors all relate to each other. So accordion goes with 0, goes with true. And same with banjo, goes with 5, goes with false. Cello, 4, true, etc. So if I want to get R to tell me which instruments have been performed, what it's going to do is it's going to look at instruments and performed, and it's going to say, all right, which of these relate to a true statement? And so this line, I've saved it into a variable as well. So I'm going to run all of these so I get them saved into my environment here. So now I can see that they've shown up. And now on this line, I want to save into a new variable just instruments that have been performed. So when I run this, I'll see that I perform shows up here. And I'm just going to check this by typing I perform and running that. And it prints out accordion and cello. And if I look, I see that's the first one, it's true. Third one is true. So that's great. So now I've got a vector that contains only instruments that have been performed. So what if I wanted to say the opposite of that? What if I only wanted instruments that have never been performed? The syntax for opposite or not in R is an exclamation point. So this line reads instruments not performed. And if I run this, it shows me the other 3 instruments. A couple other symbols are the and symbol and the or symbol. On a Mac, it's right below your delete key. And you can also use less than signs or the double equal sign, which I'll go over in a second. So this line will print out all the instruments that have not been performed and whose number of strings are greater than 0. So I see that those are 2. And this line gives me instruments that have not been performed or the strings are greater than 0. Now here's the reason why we use the arrow instead of an equal sign, is because sometimes we use the double equal sign. So if I wanted instruments that had been performed and strings are equal to 0, I can't just say strings equal to 0. I have to say double equal, because it's not setting strings as being equal to 0. It's saying when strings are already equal to 0. So it's a subtle difference, and that's really why we use the arrows and not the single equal sign, because it gets confusing. So then it'll give me that there's only 1. And if you can see, I did edit it out because it was a silly mistake. If you look down, you can see this error message. I tried writing this line, and it didn't work because I forgot the second S in strings, and it didn't understand what I meant, and it gave me an error. And here are just 2 more examples. Here I've set x equal to true and y equal to false. And I can run x and y to test if they're both true, which isn't true. X or y to see if one of them is true. The exclamation point x will give me the opposite of whatever x is, not x. So it gives me a false. And not y will give me the opposite of what y is. So it should give me true. Another thing you can do with vectors is say, here I wanted to add 100 strings to every element of the strings vector. I don't have to make a new vector over here. What I can do is I can say the original strings plus 100 and then save it over the original strings. So if I run this, then it's added 100 to everyone, and you might have noticed it changed in my environment as well. And then if I print this, it'll give me strings plus 100. In addition to just adding one number to a vector and having it apply that to every single element of the vector, you can also multiply, divide, add, and subtract vectors to each other as long as the vectors are of the same length or the smaller one is a multiple of the larger one. So here I've made 3 example vectors. A and B both have 5 variables, and C has 4. So I'm going to run these. And now we're just going to do some basic functions. We're going to multiply A and B together. And all it does is it multiplies the first element together, then the second element together, and the third element, and it outputs a vector that's also 5 long. We can divide them, we can add them, and we can subtract them. But see what happens when I try to add A and C. And these are vectors of different lengths, and one is not a multiple of the other. So it gives me a warning message. So let's add a number to A. Let's add 12. And then let's take out 2 of these numbers. So now A is 6 long and C is 2 long. So now let's replace B with C in all of these equations. So now we're going to try running all of these. And even though A and C are different lengths, it's still going to work. Because C is a multiple of A, what it's doing is it's saying, all right, we'll take the first element of these and multiply them together. So 3 and 2. I'm going to take out B for a second. We're going to multiply 3 and 2. We're going to multiply 6 and 4. And then it's just going to start repeating C. So it's going to go back to the first element. So it's going to say 3 times 6, 6 times 8, 3 times 10, 6 times 12. And that's what it's going to do anytime you've got 2 vectors of different lengths. It'll repeat the smaller one as many times as you need in order to completely multiply every single element of A. So we can do A divided by C, we can do A plus C, we can do A minus C. So that's all for now, specifically on vectors. We've done 2 lessons on them, and in our next lesson, we're going to move on to combining vectors into data sets.